Hello students, welcome to Inside Physics. Today we are going to discuss about universal law of gravitation. Okay, in gravitation topic. So, what is gravitation? So, it is a force acting between two masses. So that we can call it as gravitational force also. So, how it was actually discovered that there is a force that is which is attracting the two masses. So it was actually found out by Newton in 1665. We all know that with his famous incident that the apple from a tree is falling down onto the earth, and because of that observation he thought why the apple is actually falling down and why it is not going up. So with that consideration he actually developed a theory so that always there is a force of attraction between the masses with, which are placed with some distance apart. So based on his assumptions he proposed a famous law which is now called as universal law of gravitation or Newton's law of gravitation. So what actually universal law of gravitation says is every particle in the universe attracts another particle with a force that is actually directly proportional to product of their masses, and the same force is always inversely proportional to the distance between them. So he made these two assumptions while considering the proposing the theory of gravitational force, and with these two assumptions we can write F proportional to m1 m2 by r square. So we just picturize what actually we have taken by these two assumptions. We consider a particle of mass m1 and another particle of mass m2. They are separated by a distance r. So this distance is separating these two masses which is having mass m1 and m2. So we can say now the statement as every particle in the universe attracts another particle which is having some distance between them with a force of which is directly proportional to product of their masses and inversely proportional to square of the distance between them. So with this assumption we can write the same thing by adding a proportionality constant g, and this formula will become g m1 m2 by r square. What is the proportionality constant which we have written here? This is called universal gravitational constant. G is called universal gravitational constant. So it can be written for its numerical value, it is z is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is an SI unit, and the same thing we can also write in the CGS unit as 6.67 into 10 to the power of minus 11 here Newton centimeter square per gram square. Okay. So this is the value of gravitational constant. See, for in physics, if you want to convert a proportionality into equality, we have to take the proportionality constants. See, these proportionality constants are actually found out with their numerical value by by conducting so many experiments and observations. Based on those experimental observations, the final value of the proportionality constants like this universal gravitation constant will be found out, and we use in this relation, which is a famous formula and called as Newton's law of gravitation. Okay, see, if in this formula, if we consider there are two masses which are having a unit mass separated by a unit distance, that means we if you want to evaluate g, so the same formula can be taken for two unit masses which are separated by a unit distance. We can take as this one g into 1 into 1 by 1 square. That means this will become f is equal to z. So the gravitational constant is a force when it is a force between the two unit masses separated by a unit distance. So this value is this one in SI system, and this is in CGS system. Okay. So here if you see, we can evaluate Z with this formula. What it can be? Z is F R square by M1 M2, right? So with this relation we can write F is equal to, or rather Z is equal to FR square by M1 M2. So with this, what we have to write is the dimensional formula of gravitational constant. So we can evaluate the dimensional formula as m minus 1 L3 T minus 2. Okay. So how to take the dimensional formula from a formula like this one is that we can take up in dimensional analysis when we go through that chapter. Okay, so now we see what can be the characteristics of gravitational constant. So gravitational constant is a scalar quantity, and this scalar quantity is equal to the force I already told you acting between the two masses which are of unit mass and separated by a distance r. This is a scalar quantity, and the second one, gravitational constant is independent of nature of bodies, and is also independent of nature of medium present in between the masses. So here if you observe this force according to the law of gravitation will act along the line joining the two masses. In particular, we can say line joining the two center of masses of the particles. So here, see the gravitational constant, the gravitational force actually will be acting for very short distances, and for very long distances also, for very long distances. That means the law of gravitation will work for very short distances and for very long distances also. But it has one limitation. The law of gravitation will actually fail at some distance which is of the order of 10 to the power of minus 9 meters. The law of gravitation will fail at any distance of the order of 10 to the power of minus 9 meters, which is considered as the intermolecular distance. Intermolecular distance. So this is how we consider some of the characteristics of G and where the universal law of gravitation will work and where it will fail. Okay. This is about the law of gravitation proposed by Newton in his famous theory when he was proposing the entire concept of gravitation, why the objects are attracted one towards other. So the gravity is actually an attractive force which will be pulling one particle having a mass and with another particle which is at a distance apart. So now we consider another form of law of gravitation which is a vector form. We know every force is a vector, so that it is having both magnitude and direction. So here also the gravitational force, rather gravitation, is a vector. So how we can represent this law of gravitation in vector form, that we will see it also. So first, to consider anything like a force for a vector representation, again we will consider two masses which are at some distance r apart, m2, and the same masses are separated by a distance r. So I will consider the force acting on mass m1 because of m2 as f12, and I will put a vector representation for it. Now we are representing the force and this positions of the masses in vector form. Again I will represent this force on m2 because of m1 as f21 in vector form. So what is the position of this m1 in a coordinate system? I'll write r12 bar as the position vector of mass m1 and r21 as the position vector of mass m2. So in this way, see, 1 2 means we are measuring the distance from 1 to 2. I can represent 1 2 from here to here. R21 is we are measuring the distance from mass m2 to mass m1. I can represent this position vector in this form. Okay, this force on F mass m1 because of m2, force on m1 because of m2. So this will be pulled by the particle m2. So f12 can be represented as this arrow. Okay, the force on m2 because of m1, force on m2 because of m1. So this m2 will be pulled by the mass m1. So this will be represented in this way. So I have put double arrows for first for one f12, this one, and the position vector is also in this direction. And for force acting on mass m2, I'll put the arrow like this. So this is the representation of direction also, because force is a vector. It will act, already told you, it will act along the line joining the center of masses of two particles. Now we'll represent in a mathematical way what is actually law of gravitation. See, I'll put a minus sign before this one because this is an attractive force. Okay. So I represented in the vector form. R21 is a unit vector. I'll put r cap 21 is a unit vector and it represents the direction of the force. If you observe F12 force acting on mass m1 because of 2, and the distance r21 is we are measuring the distance from m2 to m1. Okay. So second representation for force on M2, it will be just minus G M1 M2 by R12 whole square R12 cap, represented with multiplied by unit vector, which gives the direction of M2 force acting on M2 because of M1. So okay, so the vector position vector R12, 1 means 1 to 2. We are measuring the distance from M1 to M2. Okay, see if you observe this one, see both position vectors having the same magnitude because the distance from M1 to M2 is same as from M2 to M1. We can write the magnitude of R12 is equal to magnitude of R21. Okay, so here this one I will write it as minus G M1 M2 by R21 square by minus of R21 cap. Why I have written R12 and taken as R21 and I have put minus before that? Because R12 and R21 are opposite in their direction. That's why this has I converted into 1 2 into 2 1 and I put a minus before that. So this can be again written as GM1 M2 by R21 square into R21 cap, which is a unit vector. So if you observe this equation and this equation, we can write directly as, so this one and this one. Observe this equation and this equation. We can write F12 is equal to minus of F21 bar. Okay, see the force is always attractive because of negative sign, and the force which is in between M1 and M2 or can be represented like this. These are in value, both are equal and opposite. Okay, so this is a representation of Newton's law of gravitation in vector form. Okay, now we'll consider one situation where we have more than two masses, and what is the effect on of the gravitational force on a mass by the other masses. We'll see now a system of masses, more than two masses. First, consider a mass m1 is present here. So there are some masses m2, m3, m4 present around it. So obviously they will be having gravitational force of attraction between them because they have mass. This I will write it as R12 as a position vector, and this I will write R14. This distance is represented by the vector R bar 13. So this is a mass m1, m2, m3 and m4. So if I consider the gravitational effect on m1 because of all the other three masses, how to get the total effect, that means total force acting on m1? Here we consider the principle of superposition because law of gravitation obeys principle of superposition when we consider a system of masses, principle of superposition. It says the net value will be added up to get a net value on a particular mass. So with this we can write F gravitational force net on mass m1 is equal to, you can write F bar 1 2 plus F bar 1 3 plus F bar 1 4. Force acting on mass m1 because of 2, force acting on mass m1 because of 3, force acting on 1 because of 4. So in this way we can represent again as in the form of law of gravitation r21 square. Okay, so plus gm1 m2 by r31 square plus gm1 m2 by r41 square, and we can add an unit vector for all of this because this is a vector representation. Okay, so sum of all the forces, gravitational forces acting on mass m1 because of all the other three masses. So in this way law of gravitation obeys principle of superposition, and we can add up all the gravitational forces acting on a mass because of their individual effects. So this is the consideration and explanation for law of gravitation. In the next class, we will further discuss the other topics in gravitation in detail. Okay, thank you.